All right, we're going to continue here uh, comparing two population means. And in this case, we're working with two samples that are independent. Now, the difference is I do not know the standard deviation of the two populations. Okay, and when that happens, you do not know the standard deviation of the two population. You need to be very careful. You're going to follow these steps, but you need to make sure that something is said about the population variance. And in this problem, I'm working with the case when the population variances are not equal. So let's go over the problem. It says here, the results of a state mathematics test for random samples of students taught by two different teachers at the same school are shown below. Okay, so here's the statistics for teacher 1 and teacher 2. Can you conclude there is a difference in the mean the mean mathematics test scores for the students of the two teachers? Use alpha equal 0.10, assume the populations are normally distributed and the population variances are not equal. So I want to know if there's a difference teaching the same class, same course with two different teachers. So because the teachers they're not the same teacher, there's two different teachers, that means the samples are going to be independent. So when I'm looking at my step number 1, that's one of the first things I need to check. You can see here that I'm doing step 1. First step said check if you know sigma 1. I'm sorry, make sure you do not know sigma 1, sigma 2. In other words, I do not know the standard deviation of the population, and nowhere here that was mentioned. So that is a check. The next thing I need to check, make sure the samples are random. So they were collected, the information was collected from random sample. Look, that's one of the things the problem says. The next thing, make sure that the samples are independent. Okay, and I just told you that because there are two different teachers teaching the same course, how one teacher teach and how the class perform for that teacher is going to be different from the other one. So yes, they are independent. Okay, the next thing, make sure that the populations are normally distributed. When you look, yes, it says here the populations are normally distributed. So you can basically see I met all the conditions of step number 1. All right. And because I'm working with the case that we do not know, not that we do not know, that the population variances are not equal. How do I know that? Because it says it right here. So I did my check. Step 1. Step 2. Let's state the claim mathematically. I'm going to underline the claim in blue. And you can see the claim is right here in this sentence. Can you conclude there is a difference in the mean mathematics test score? So I'm going to underline there is a difference in the mean of the scores, the test scores of the two math teachers. And how do I translate? See, that's the claim. How do I translate? We're doing step number 1 here. And what I'm saying is that the mean of teacher number 1, if there is a difference, it means that they're not equal. That's what that means. Okay, so the mean of teacher 1 is different than the mean of teacher 2. Okay, and this is my claim. Let me put that in parentheses. Claim, that was my claim. Don't forget that every claim has a counterclaim. So how do we find the counterclaim? We state the opposite. So what is the opposite of mu1 not equal to mu2? We say mu1 is equal to mu2. Okay, and that is my counterclaim. Now remember, we need to label the claims as HO and HA. Whatever has the equal sign is going to be HO. Whatever doesn't have the equal sign, that will be my H1 or sometimes HA. And I did step number 2. Let me put a check mark. Step 3, I need to specify, by the way, this is step 2. I put step 1, but it's step 2. Step 3 is find out who's your alpha, your level of significance. And you can see it's right here, 0.10. So that's what I'm going to put here, 0.10. Step number 4. Okay, I need to determine the degrees of freedom, but I need to choose the degrees of freedom of the smallest one that I could get. Here's what I mean, because you have two samples and each sample has different size. Okay, I'm gonna do the degrees of freedom for each one. So because this is teacher number one, df1 equal n, which is 8, that's the teacher number one, minus 1, I get 7. Let's do the degrees of freedom of teacher number two. So df2, okay, who is my, what was the sample size that we used there? 18. So 18 minus 1, I get 17. So you can see I had 2 degrees of freedom, but which one I'm going to choose? The smallest one. So I'm going to choose 7. And that's what step number 4 is about. And we did step 4. Here we go now with step 5. Okay, so step 5, I'm going to do it up here. We're going to draw the picture. Here's the picture. Now I need to shade a tail, one tail or two tails. Who decide that? H1. And H1 has the not equal, so that means we're going to shade two tails. Okay, and that's what I'm doing this now. Shading the left tail, and then I'm going to shade the right tail. And that's it. That's step number 5. Step number 6, we have to find something called the standardized test statistic. So it's a number that I'm going to calculate using a formula. Here's the formula. You can see it's a long formula. So I'm going to put it right here, step 6. And what do we do with formulas? We plug in. So let's start. Okay, in my first parenthesis, I'm going to plug in x bar 1, 473. I'm going to type that better. 473. And what you're going to do, subtract that from x bar 2. And who's my x bar 2? 459. Okay, and I'm going to close the parentheses. Take away, okay, mu 1 minus mu 2. Now, because we are assuming the mean, there is no difference, okay, that's what we usually do. We're going to assume there's no difference. That means that the means of the two populations are equal. And if the means of the two populations are equal and you subtract them, that's why you always get 0 here. So that's what I'm going to put 0 there. Over, now we're going to have the square root. Okay, we're going to have S1, so 39.7, and I'm going to square that. Okay, and then whatever answer I get, I'm going to divide it by N1, which is 8 in this case. Plus, now I'm going to do S2, 24.5. I'm going to square that. And I'm going to divide that by N2, which is 18. Okay, and what I'm going to do is I'm going to use my decimal calculator. Here it is. And I'm going to, whatever I wrote here, I'm going to type it in here. So fraction, I'm going to put parentheses, 473 minus 459, close the parentheses, minus 0. That's on the top. On the bottom, we're going to have square root. Then we have one fraction, 39.7 on the top, square over 8. Okay. And let me make sure I'm typing the formula correctly. Yes, I am. And then plus, and then I'm going to put 24, the fraction first, 24.5 square, and then over 18. And you can see my t value. T scores and z scores, you always use 2 decimal places, so my t is 0.92. Now don't forget that the number we get in step number 6, the test statistic, is used to label the marks where you shaded. Because it came out positive, that means the right mark here is 0.92. And then the left mark will be the same number but opposite sign, so 0.92. Okay, and we did step number 6. Okay, now we're going to do step 7. We're going to find the p-value. Now, because my formula is start with t equal, that means that I'm using my t calculator, not the normal, no, the t calculator, this one. So I need to fill in these boxes. Okay, the degrees of freedom, remember you choose the smallest one. We chose 7. That's what we're going to put here. Oops, not in that box, in the one above. 7. And who's my t value? 0.92. and then you're going to click calculate. Okay, and don't forget you're going to get 3 answers. Okay, now which answer you're going to use depend on your picture. So my picture is a two-tail, so I'm going to use the last one. So my p-value is point, usually p-values are 3 decimal places, so it will be 0.388. So this is step 7, and I'm looking for my p-value, so 0.388. Let me verify that I put that number correctly. Yes, I did. And we did step number 7. Now we're going to go step 8. What is step 8? That's when I compare my p-value against my alpha. And who's my p-value? 0.388. That's what we got in step number 7. Who's my alpha? That's step number 3, 0.10. And from left to right, P is bigger or smaller? Is bigger. And you looking at the chart here, when the p-value is bigger, our decision is going to be fail to reject HO. Okay, and that's what I'm typing right here. Okay, based on this chart. And we did step number 8. Let's do step number 9. Okay, step 9. What we're going to do now is make the interpretation. It all depends on this chart. What was your decision and where is the claim? My decision was fail to reject, so I'm in this row, second row. And my claim is in H1, which is the equivalent of HA, so I'm in my last column here. Second row, last column. Look what it said. There is not enough evidence to support the claim. So not enough to support the claim. What claim? Okay, that there was a difference between, okay, the mathematics test scores from the 2 teachers. Okay, and that's how you work this out. Hope this helps.